Hi guys, let's learn lattice enthalpy and Born Haber cycle. Why is common salt so stable and why doesn't it simply fall apart into ions? The answer is hidden inside something called lattice enthalpy. In ionic compounds like sodium chloride, positive and negative ions are held together by strong electrostatic forces. To separate these ions completely into gaseous ions, energy must be supplied. This energy is called lattice enthalpy. For example, in sodium chloride, a large amount of energy is needed to break the crystal lattice. That's why lattice enthalpy is usually highly endothermic. But scientists cannot measure lattice enthalpy directly, so they use a clever energy cycle called the Born Haber cycle. It applies S law to calculate lattice enthalpy step by step. The process includes sublimation, ionization, bond dissociation, electron gain, and formation enthalpy. When all these energy changes are added together, the lattice enthalpy can be determined. Now, what happens when salt dissolved in water? The ionic lattice breaks apart and water molecules surrounded the ions. This process involves two energies. The balance between them decides whether dissolution absorbs or releases heat. If hydration energy becomes greater than lattice enthalpy, the compound dissolves more easily. That's why some ionic compounds dissolve quickly while others do not. So even simple table salt hides an entire energy story inside its crystal structure. Follow and subscribe Nawal's Academy for simple chemistry.